The collector vanishes off the screen around 2:13 a.m. Its cameras saw black nodules scattered throughout the abyssal plain just a moment ago. The lens has been engulfed by sediment, leaving only brown static. The riser pressure alarm then goes off. Once, the number increases, stops, climbs once more. The ship is in broad Pacific waters above you. More than 4 kilometers below you, a remotely operated piece of equipment is crawling across the ocean floor. It is connected to the ship via electrical wires, a flexible hose, and a vertical pipe that hangs through the water like a steel spine. A thruster warning is issued by the bridge. The ship has started to leave its corridor, only a few meters. But those meters pull sideways on invisible or inaccessible gear deep below. You run the risk of overwhelming the system if you keep collecting. Material may settle inside the riser if you stop too soon. You might find that the collector has already been ensnared when you start your recovery. This isn't your typical mining. The machine does not have a driver. No rescue team is waiting close to it. Thousands of meters of water, pressure, and darkness separate each component from you. Tonight, you'll be running them all. You are participating in an approved test campaign aboard a civilian deep-sea mineral collection vessel. The goal is a field of polymetallic nodules, which are rounded rocks with metals like nickel, copper, cobalt, and manganese that are free on the deep sea floor. The vessel is not a single machine, and the process is experimental. It's a chain. The spacecraft stays in place over a shifting target thanks to dynamic positioning computers. Wind and stream are countered using thrusters. The bottom is mapped by survey vehicles. The collector is lowered via a launch system. Kilometers of cable are handled by winches. Nodules are gathered by the collector. They are carried upward by a riser. The mixture is kept flowing by pumps. Solids are extracted from seawater in a dewatering facility. What the operation leaves behind is determined by monitoring vehicles. The other links are responsible if one fails. The device that keeps the ship still is where you start. The ship looks motionless from the shore. It isn't. The hull is pushed by the wind. It is elevated by swell. Below, the current pushes. Every force tries to pull the ship out of the collector's path. The dynamic positioning system uses several thrusters to counteract motion, wind, heading, and location. You keep an eye on the distance between the ship, riser, and collector, as well as the available power, thruster load, and reference signals. This ship is committed to its mission. The riser will bend more forcefully if you go too far. The umbilical cord tugs. Unless the ship above stays where it promised to be, nothing below is under control. The survey team then finds difficult terrain directly in front of them. In areas that have never seen sunlight, you now require eyes. While sonar and sensors map the surroundings, the autonomous underwater vehicle drives first, adhering to a predefined grid. It searches for areas the collector should stay away from, slopes, obstacles, and changes in the nodule field. The ROV is still affixed to the vessel. Cameras, sonar, lights, and thrusters can all be used to control it. The water is black beyond the lamps. Unexpected things show up. A slow-moving animal in the cold, a cable through soft silt, an outcrop of granite. You're searching for more than just a route. You are recording what was there prior to the passing of the machinery. A safer path around the difficult terrain is indicated by the ROV. The path changes, but you have to descend a machine the size of a tiny tower into a moving ocean before the collector can function. The collector appears gigantic on deck. It appears delicate as it hangs over the lake. Lifting points, guards, cameras, tracks, and connections are inspected. The weight is then transferred to the launch system. As the ship slides beneath it, the collector gets up from the deck. A machine entering water moves differently from one hanging in the air. The collection descends toward the surface when the ship ascends a swell. The lifting wire tightens as the ship descends. Although motion adjustment lessens the burden, the sea cannot be stopped by it. When the collector comes into contact with the water, it sinks and disappears in white spray. Although the operation becomes heavier, the deck becomes quieter. The cable, strain, and time between command and consequence increase with each meter downhill. There is no crew for the collector. An umbilical that extends thousands of meters into the deep provides it with power and control. It is paid out with controlled tension by the winch. If there is not enough, the cable may move erratically. Too much, and hazardous loads are carried by the connection points. You observe the vessel's movements, descent, length, speed, and tension. Cameras first show suspended particles, followed by flat sediment. The tracks come to rest. You advance the control. Crawling across the abyssal plain is the collector. Soft sediment is compressed by its tracks. The collection head travels near the ocean floor. Through the ship's moon pool, a lengthy riser pipe lowers toward the ocean floor. It is connected to the collector by a flexible hose near the bottom. Inside, a slurry of seawater, sediment, and nodules rises. That combination needs to be kept flowing via the lift system. Solids may start to settle inside the line if there is insufficient velocity. Pumps, pipe segments, and connections are under more stress when there is an excessive amount of load. Pressures are monitored throughout the system. Material rises toward the vessel, lift pumps provide energy, and feed enters below. However, the riser is not a stationary pipe. Its whole length is affected by current. Movement on the surface enters the structure. The collector moves at a different scale than the ship. Small mistakes are magnified by 4 kilometers of machinery. Additionally, stopping is no longer easy once the material is flowing upward. The surface plant needs to be prepared for everything that is already en route. When the first nodules arrive in the vessel, they are combined with fine silt and seawater. Water is eliminated, and solid material is directed toward storage by screens, separators, pumps, and conveyors. Pipes are pounded by water. Conveyors have vibrations. A portion of the abyss is carried into the ship by dark nodules. You keep an eye on tank levels and flow rates. The issue moves backward if the facility is unable to process the material as fast as the riser delivers it. Pressure increases when a screen is obscured. A transfer point may overflow if a conveyor stops. The collector may slow down due to a pump failure. The nodules advance in the direction of the grip. The test plan governs the management of separated water. Additionally, a different fleet of machines is monitoring the changes brought forth by the procedure all around the ship. AUVs traverse the region. The capacity of one azimuth thruster has been lost. Although the load is increased by the remaining units, the ship deviates from the intended line by many meters. The collector moves forward below. The riser bears a larger lateral load than the other. The angle of the flexible hose varies. Tension in the umbilical cord increases. Collector outlet pressure increases once again at the same time. Sediment is all that its cameras capture. You no longer have a single issue. A number of your machines are starting to interfere with each other. The collector should be halted, according to the bridge. Solids settling in the line is a concern for the lift crew. The subsea team anticipates challenging conditions. The environmental team requires verification. Every department is right. The decision is risky because of this. First, you cut back on collector feed. The car decelerates. The lift system keeps going long enough to remove any material that has already risen. The bridge redistributes thrust among the healthy units and modifies its heading. The pressure starts to level off. Umbilical strain then rises. The collector is no longer in motion. The car is tilted over its track according to sonar. One side is positioned lower than the other. The machine does not go forward, but the tracks react. It could be hidden by disturbed material at the rough spot or in soft sediment. A mechanic cannot be sent down. All you have are cameras, motor currents, pressure readings, and brief test orders. Turn one track around. Take a moment. Minimize the load on the collection head. Take a moment. Adjust the vehicle's angle. Take a moment. The collector is the target of the ROV's redirection. At last, Its lights emerge through the silt. The collector is seated in a small depression with sediment surrounding one track. The picture is poor but sufficient. There is nothing wrong with the machine. Not quite yet. Before the weather reduces the vessel's positioning margin further, you must release it. The entire ship is covered by the recovery plan. The safest heading is held by dynamic positioning. Tension is maintained via winches. The riser is cleared by the lift crew. While the surface facility processes the leftover material, the ROV keeps an eye on the collection. A tiny reversing movement is ordered. The collector does not climb free. Instead, they shift. Tension in the umbilical cord increases. You quickly stop. A modified track angle and reduced strain on the collection head are used in a second attempt. The tracks change direction. There are sediment eruptions. The car vanishes for 2 seconds. Then the header is altered. Rising is the low side. The collection retreats into more stable ground. The screen is filled with tension. The riser reverts to its anticipated form. The ship has returned to its operating corridor, according to the bridge. No one applauds. Too much ocean separates you from the machine you nearly lost, and too much machinery is still in motion. The collector is examined by the ROV. Instead of failing, the run is suspended. The distinction is judgment at sea. The ship appears nearly unremarkable during the day. While engineers examine the data, the collector rests securely below. Thrusters maintain their place. The riser is still in use. AUVs are still mapping. The processing facility is examined and cleaned. Each equipment did its job. The plant produced cargo. The riser raised stone. The launch system lowered the vehicle. The collector traversed the abyss. The umbilical carried control into darkness. The positioning fought the weather, and the monitoring systems documented the change. However, no machine was able to comprehend the entire system. A thruster alert, a pressure spike, an environmental reading, and a jammed track were all turning into one emergency that only the passengers could witness. That's the unspoken truth of running a deep-sea mining ship. You are not in charge of different computers. From the bridge to the abyssal plain, you are in charge of a single, massive machine. Pressure, current, darkness, and delay are the divisions of its constituent parts. Its intent is disputed much beyond the ship, and its errors can persist after the ship departs. The collector is not the most hazardous device on board. The riser isn't it. The processing factory isn't it. When every system is technically operating, it is up to humans to decide whether to proceed, yet the difference between damage and control is getting less. The collector is waiting for its next order 4 kilometers below. The ship maintains its position over it. And before anyone can say they have conquered the deep ocean, they need to respond to a more difficult question. Can something that took millions of years to form be removed by a machine without going beyond what anyone can comprehend?